This video is about rational exponents, exponents that look like fractions. In its most general form, a rational exponent is going to look like this, a raised to m over n. And we're going to consider two cases. One, when the base a is a number, such as in here. And the second case will deal with a base being a variable, such as in here. When the base is a number, follow this formula. A raised to m over n should be equal to, within parentheses, nth root of a raised to m. Notice that the denominator becomes the index of the radical, right? And the numerator goes outside as exponent. Okay, that's for the case when a is a number. Now, what to do when a is not a number is some variable such as x, y, z, in general any letter of the alphabet, English alphabet. So if your base is a variable, follow this. A raised to m over n is equal to nth root of a raised to m. No parentheses, right? No parentheses. So I'll explain these two cases to you via these two examples. First example, example number one, suppose they say compute 8 raised to 2/3. Solution. A raised to 2/3, since the base is a number, the number 8, should be equal to cube root of 8. Remember, cube root of 8 first, within parentheses, and then raised to this guy 2. Remember, denominator becomes the index, the radical, and the numerator is the exponent outside. Okay, now let's get this done. Cube root of 8 is just the number 2, right? And 2 squared is just equal to 4. Just equal to 4. And there you have your final answer. Now, let's take a look at the other example. What happens when the base is not a number, but instead a variable, such as x? Suppose they say simplify x raised to 2/3. Turns out this is going to be much easier because now we follow this formula, the second one. X raised to 2/3, since x is a variable, is simply equal to the cube root of x raised to the second power. No parentheses needed, and this is the final answer. Okay, so now let's consider more examples, different forms. So let's go ahead to the next page. 3 more examples here. Let's start with this one, example number 3. 125 raised to negative 2/3. Solution here. Notice we are dealing here with a negative exponent, so this should be equal to 1 over 125 raised to 2/3. 2/3 becomes positive now, right? Remember, when you deal with negative exponents, you write 1 on the top, and then you write this stuff on the bottom with this exponent positive 2/3. Now, further, we know what to do here, right? 125 raised to 2/3. Since the base is a number, is simply equal to this cube root of 125 raised to the second power. Now, cube root of 125 is just equal to 5. And 5 squared will be just equal to 25, right? So the final answer should be 1 over 25. Good. Let's take a look at example number 4. They say now simplify x raised to 1 over 5, 1/5, all that raised to the third power. Solution. Here, first I'm going to apply the power rule, the one that says that if you have two exponents, one right next to the other, then you just have to multiply the exponents, right? Whatever they are. 1/5 must be multiplied by the number 3. So what is 1/5 times 3? Well, once you place the number 1 below here to make it look like a fraction, 1 times 3 is just 3. 5 times 1 is just 5. So x raised to 3/5. Okay, now simply write this rational exponent in radical form. How? We'll take the denominator, make it the index of the radical, and then x should go inside raised to the third power, right? This is the way you deal with a base that is a variable, such as x. And then that's it. This should be your final answer. Let's take a look at another example here. Evaluate 25 over 9, all that raised to negative 1 over 2. Solution here. Remember, when you deal with a base that looks like a fraction, that is a fraction, raised to a negative exponent, we have this nice rule. This guy is equal to b over 8. We flip the fraction, right? And then this becomes now positive, p over q. So let's apply this rule here. This guy will be equal to 9 on the top, 25 on the bottom. We flip the base, fractional base, and this negative 1/2 becomes positive 1/2. Right? This negative sign disappears. So now write this in radical form. So this will be a square root. Remember, the index 2 goes here. We don't need to write the index 2. So we're dealing with the square root of 9 over 25. And the square root of 9 of 25 is, square root of 9 is 3. Square root of 25 just 5. And then we're looking here at the final answer.